All right, so in this bell work here, we have a riddle. So sometimes people think I look like a U or an upside down U on a coordinate plane. Also, I like to make my highest power on my X the degree of 2. What am I? So what it's saying is it's like this equation that has x squared in it, or x to the second power. This is highest power. So anything that has an x squared as the highest power is something what we call a quadratic. But the shape that it makes on a graph or coordinate plane is a U shape, and we call that U shape a parabola. So today I want us to introduce quadratic equations or quadratic functions. And we're going to be graphing quite a few parabolas today. I also want to mention, kind of like a sneak peek into what this unit's project is you're going to have to be looking for a real world parabola. So what I mean is you're going to be looking for a parabola that something in the real world that forms the shape of a parabola. So it could be an object, or it could be like a motion as well. So if you throw a ball, you make that kind of U shape when you throw a ball. Or that trajectory shape. So anything that's also a motion can also be a parabola. So over this past week, I want you to think about what is going to be the parabola that you want to model. So start thinking about that. But more into today's lesson here, let's get to the next slide. Alright, so in this slide here, let's go over how do we graph a quadratic equation that's in vertex form. So vertex form are these parentheses, and when you have it in vertex form, you typically want to look inside your parentheses and see oh, what's the shift? So in this case, you have a minus h. So anytime you have a minus sign inside, that's saying you have to move right if there's a minus sign. If there's a plus sign, you're going to move left. And then if there's a plus sign outside, you're going to move up. And negative means down. So inside the parentheses is your horizontal shift. So if it's a minus sign, you move right, plus sign left. On the outside tells you your vertical shift. So it's either going to be plus sign is up, negative is down. And then the h and the k will be the number that helps you plot your vertex. So a vertex is when you have a parabola. So let's say you've graphed a parabola. The vertex is basically the middle point of your parabola. And that's important because that helps you figure out if this is a minimum or a maximum. So for when you're plotting points on a quadratic, you need at least 3 points. So you need to have 3 coordinate points to draw a parabola. So make sure you have 3 points. And what you do to get the extra point here is you grab the slope. So technically the slope you can use is outside, the number that's outside of the parentheses or next to the x. So I mean slope that you can only use it to help you find an extra point, and you want to only use it one time. After that, it's really inaccurate to use that as your slope because this is a quadratic equation, so it doesn't work like a linear equation. So what you do is take your number, in this case a, and you always make the slope over 1. So in this case here, if this is the vertex is where it splits up in the middle. And we can split it up using something called the axis of symmetry. And the axis of symmetry basically helps us mirror a point to the other side. So that way you can create the extra point. So if you already have this point, you want to get your third point, you can reflect it over the axis of symmetry. So basically, make sure you know your shifts so that you can figure out the vertex. And then you'll use the slope to get your extra point. And then you're going to use the axis of symmetry to reflect to get your third point. So you need 3 points to draw a parabola. So let's first just practice how do you find the vertex, because that's going to be a really important skill to know. Okay, next slide. All right, so these are suggested homework problems that I would look into. This is from chapter 10.2. So in this unit, I'm going to actually have two chapters, chapter 10 and chapter 6. So we're going to just start off with chapter 10. And you're going to have to find the vertex. So here's the equation. So to find the vertex, you need to look inside the parentheses first to figure out if you are shifting left or right. So this is a plus 3. Anytime you have a positive sign, you are shifting left. So left 3. There's a minus 4 on the outside, so you're going down 4. So if you were to draw like a quick coordinate plane here, this is left 3, so that gets you to negative 3, down 4, so negative 4. If you plot a point right there, that coordinate's going to be negative 3, negative 4. Okay, and so that's how I can quickly figure out the vertex. So the vertex is the middle of the parabola. Right now we're just trying to find the vertex. So this next one here is a minus 5, and so that's going to be right 5, down 8. So if I were to go right 5, I'm going the positive direction. Down 8, it's going to be in the negative direction. I think that's negative 8. So that'd be right here. So this would be 5, negative 8 as my vertex. So hopefully this doesn't feel too heavy for you guys. In the next slide here, I am going to show a little bit trickier ones that don't really have parentheses, and see how we deal with them. All right, so in this problem here, notice how the first one has an x squared plus 4. And this one has just a parentheses. This one doesn't have a parentheses. This one has a parentheses but has no number outside of the parentheses, which is kind of strange, right? So give yourself a moment, see if you can figure out the shift here and to find the vertex. As you guys are doing that, I'm going to write the formula here that we saw in the definition slide. All right, so this first one here has an x squared plus 4. So I want you guys to notice that there are no parentheses here. Typically, you would put the parentheses like here where the x is, right? And then you would see like, oh, then it's squared, right? And then you would have a number inside. But there is no number inside this parentheses. So that means that there is no horizontal shift. It's like if you were to say that this was x minus 0 squared plus 4, right? If I were to put these set of parentheses there and make this inside 0, well, x minus 0 is still an x. So because there's no number inside, there is no horizontal shift, meaning it doesn't go left or right. But the outside has a plus 4, and so any number after the square is being added or subtracted on tells you your vertical shift. So this is a plus 4, so this is saying up 4. So if you were on your coordinate system and you didn't shift left or right, you would still be at the origin, but then you have to go up 4, get you right about there. So that coordinate point there is 0, 4. So this would be 0, 4 for the first equation. And that's it. So anytime x doesn't have parentheses wrapped around it, it's probably likely that there is no horizontal shift. But if you do see an added number, if it's added a number or subtracted of a number after the square, then there might be a vertical shift. So this one has x plus 3, so you do have a horizontal shift. It says left 3, so this is going to be left 3. But notice how there's not a number out here after the square. So if there's not a number out here, right, that means there are no vertical shift. So it's like you have a graph, you went left 3, so you're at negative 3, but you didn't move up or down, right? So there's no vertical shift. That means you had to sit on the axis, or where the y here equals 0, right? Y equals 0 here, so it's just going to sit right there. at negative 3. And so this is your vertex. It looks like it's at negative 3, 0. And then that's it. That's all you can do. So now that we've kind of gotten to the rhythm of things of getting our vertex, let's see if we can graph a parabola. All right, so in this problem here, we're going to answer these 4 questions and make a graph. So first off, let's find the vertex, because the vertex is a coordinate. And remember, we need 3 points. You'll need 3 points plotted for a quadratic, okay? So this one says plus 2 on the inside of a parenthesis. So this is going to say, in this case, left 2. And then you have a minus 1 outside. So this is down 1. So if I go left 2, down 1, I'm right here. So I'm going to put a little v there for my vertex. And so this here is at negative 2, negative 1. I also want to mention I need my axis of symmetry. So the axis of symmetry is what will cut the parabola in half, and it always goes through the vertex. So I'm just going to draw an axis of symmetry. And notice how the axis of symmetry goes through the x-axis, this is the x-axis, and it hits the x-axis at negative 2. So we call this x equals negative 2. And axis of symmetry is always x equals some number. So in this case, x equals negative 2. And that's because it hits the x-axis at a certain number. All right, now we need more points. So to get more points here, what you're going to do is you're going to use the slope. So the slope here is really, a 1 in front of this x. So the slope would be 1 over 1. So the number in front of x, in this case 1, you're going to use that as your slope. And from the vertex, you're going to go up 1 over 1 and plot. But you're going to use the axis of symmetry to reflect. So if that point's there, you're going to go up 1 over to the left 1 to reflect to make the same point but the opposite side. Then we're just going to connect the dots because we have 3 points. And we can make our parabola now. And so there we go. Now for domain is talking about your x values here. Take a look at the graph. This arrow points to the left and this arrow points to the right. So if you're going to the left here on the x-axis, you're heading to negative infinity. And if you're pointing to the right of the x-axis, you're going to positive infinity. So the domain here goes from negative infinity to positive infinity, or you can say all real numbers. Whereas the range here is talking about the y values, and the y values become more limited, right? Because in this case, looking at the parabola here, the lowest y value that this can be is at the vertex, which is at negative 1. So this can go from negative 1 to, well, there's arrows pointing up, so it's going to extend to positive infinity. So we're going from negative 1 to positive infinity. Now notice at negative 1 here, it does have a solid dot, or a solid circle, so you're going to use a bracket on the negative 1. Make sure you use a bracket. And then that's it. I've answered all of these questions, and I have a graph that has 3 points on it. So, to summarize everything, you're going to first always figure out the shift to figure out the vertex. Then you're going to use the slope to figure out the other 2 points, and make sure you draw that axis of symmetry to help out to get the 3rd point. All right, let's try out one more before I give you the exit ticket. Okay, so this one here has a negative 3 on the outside, but before we look into that, let's look inside the parentheses to figure out the shift. This has a minus 2 on the inside, so this is saying right 2, and a plus 1 on the outside means up 1. So I'm going to go right 2, up 1, which puts me right there on my vertex. So like I said, I like to put a little v there so I remember what coordinate is my vertex. This is at 2, 1. And I like to draw an axis of symmetry through my vertex in the beginning so I don't forget that that's the axis of symmetry. And so this is at x, because we always write axis of symmetry with an x, and it hits it at 2. So this is x equals 2. So my axis of symmetry is at x equals 2. And for the next point that I need to plot, remember, in this case I only have 1 point now. So I want to grab my slope to help me get the next point. So my slope here, or the number in front of x, is negative 3. So that means that my slope is negative 3 over 1, because we always put our slope over 1. But this is a negative sign, so that means I have to go down 3, 1, 2, 3, and it gets about right here, and then right 1, we get it about right there. So it looks like, oops, here we go. Looks like we're right here on the graph. And then if this is the axis of symmetry, I want to reflect it, so I'm going to go down 3 over to the left now. And then draw my curves. So this is both pointing down this time because the parabola does look like it's pointing down after I drew those points. So like I said, the domain here, this is pointing to the left technically, and this is pointing to the right. So it's going to negative infinity and positive infinity on the x-axis. So the domain is going to be all real numbers. In fact, every quadratic's domain is all real numbers. Okay, this will always be the answer for every domain of a quadratic. As for range, notice that the highest, or actually let's start with the lowest. So notice how these arrows point downwards. Well, if they're pointing down, that means that they're heading towards negative infinity, right? Whereas the highest y value here is at 1. Notice that at 1, this is kind of the maximum, so it goes from negative infinity to 1 for the range. And we always use parentheses on infinity and a bracket on the number, so the negative 1 gets a bracket. And that is it. I have my graph. I've completed these questions. Hopefully this gives you a better idea on how you can graph a quadratic. See if you can do the exit problem. Alright, so here's the exit ticket. All you're asked to do is to graph this on a coordinate plane and see if you can fill out the questions below. So I hope this video was helpful. Until next time, guys. Bye!